In this video, we are going to see how we can separate the interface from the implementation. And we will be doing this in the same interface file. Let's look at the code because that's how it's going to be easy to see. Here we have a module file doing what we have been doing all along. We have our module thing, we have our declaration down here, and we have our module purview. But in the purview, if you look carefully, you will see that we just have declarations. We don't have implementations. We have the add function here declared, the greet function, the print name length function, but the implementations are nowhere to be seen in this export block. And this is one way you can organize your code. The implementations are still going to show up in the same file, but they won't be in the export block. I have to say that this is one way you have to organize your code. We will see other ways, including separating things in separate files, and you will have to decide on what works better for your case. Now that you know this, I think it is high time we headed over to our editor and saw this in action. Okay, here I am inside Microsoft Visual Studio, the IDE or editor we chose. I already have a project created so that we don't waste time creating it, but I have to make sure to show you that you have to enable C++20 for modules to work. We go to properties, let's do it together. Let's not be too fast. So right click on the project, do properties, go to C and C++, choose the language and choose C++20 here. You also have to go to general and go to scan sources for module dependencies and set this to yes. This is the requirement for what we want to do to work inside this IDE here. Now that we have this, we can create our module file. Let's go to add new item, and it is going to be a module interface unit. We are going to name it math, and it is created now. And as we always do, we will go to the Git repository. Please go to this chapter under this lecture, separate interface from implementation, same file. And we have the files that make up this project. Open the interface file and copy row to copy all the content in this file, and we will put all this inside our newly created module file here. So I am going to paste this. We have the global module fragment, we have our declaration, we have our export block, which only has declarations and no implementations or definitions, and implementations will show up on the outside below this export block here. This is one way you can organize the code inside your module file. Please notice that for the class, we only have the class definition, but the implementations for the methods, let's see, we have a constructor which is not implemented in the class. This is what I wanted you to see. This two-parameter constructor here is implemented on the outside in this implementation section inside this module file here. The rest is really what we have seen before. Nothing more to explain here. We have our includes, we have our import. Again, if you have an import like this, if you are compiling manually, you have to make sure to compile this header unit first before you compile things that depend on it. I hope you know this by now. Let's go to the Git repository and grab the code for the main file. Let's copy it, come back to our IDE, delete whatever we have in here and paste in the new code. Now I think we can compile, but before we do, notice that we are importing math stuff. Math stuff is the module we declared here, and we are able to use it in the main file here. This is all I want you to see. Let's try to build the solution, and the build is good. Why are these squiggles not going away? They went away, and we can try to run start without debugging, and it is going to give us the expected result here. This is how you can separate declarations from implementations in the same module file. Now that you have seen this, the next thing I'm going to do is just to show you how to compile this on different compilers. If you don't care about that, you can stop here and go to the next lecture. But I strongly recommend to see all these little nuances of how you compile on different compilers. So let's go to the Git repository, open the README file. We will see that we have the option to compile with GCC. I will be using GCC on my Windows machine here. So let's do that. Let's come back and go to PowerShell. And we are in this project. This PowerShell window is opened in this location of this project here, and I have access to G++. If I do this, it will show me the version G++. If I can type today, it's going to show me the version. So let's try to compile this. Before we compile, you can ls to see the content. You see that the main files we have are main.cpp and math.ixx. The rest here is the noise that the IDE, Microsoft Visual Studio, is using to set up the project here. But the main meat of this application is these two files. So let's pass the GCC command to precompile our header unit. It is going to pass. Let's come back to the Git repository and grab the other command, which is going to compile our module file. Let's copy that, go to the terminal and paste that in. Let's go back and compile the main file and link into the Rooster executable here. So we can grab that and paste that in here. If this goes through, it is going to give us a Rooster file that you can see down here. And if we run it, it is going to give us the expected result. And we just compiled using the G++ compiler on Windows. Let's try to also use Clang on Windows. But if you remember what we have done before, we have to make sure to use the command prompt. We don't have to use PowerShell because PowerShell is going to give us problems we don't want to deal with. Let's grab the first command here. And I am going to hop over to my command prompt. But before I do, let's clean up what we had before. So let's do ls to see what we have. We have an object file that we don't want. We also have Rooster. So let's remove Rooster and remove any object file from this folder. And it is clean now. We also need to move the GCM cache folder. So let's remove that. It was generated by GCC and clear. And we can come back to our command prompt and run the command to precompile our header unit IO stream. Let's pass that. It is going to give us a warning that we are going to ignore for now. The important thing is that it works. We need to compile our module file. Notice that we have to make sure that the output PCM file has the same name as the module that we are declaring in our file here. This is really important. Again, if we come back to the file, notice that the module name is math stuff, and we have to make sure that the output PCM file also has the same name as shown here. I hope you can see this. Run the command. It is going to do what we want to do. If we do ls, let's do dir because we are in the command prompt. We should have our PCM file, which is generated. You can see it right here. Let's go back and run the next command, which is going to compile our main file into an object file. So we grab the command, we put that in here, and it is going to give us an object file. dir, we should have the object file generated right here. We are making progress. Let's come back and compile our module file into an object file. This is the command to do that. We put that in place, we run it, do dir. It is going to be available right here, the object file that we want. We go back to grab the last command, which is going to put everything together, and it is going to give us a Rooster binary that we are looking for. Let's run the command. If we do dir, okay, now that we have the Rooster file, we can run it, and it is going to give us the expected output. This is how you can use the Clang compiler on Windows to compile this project. We can also hop over into our Docker container. I have it opened in this developer PowerShell here. Okay, so this is inside my Docker container. If you don't know how to set it up, please watch the first video in the chapter. I showed you instructions on how you can get this set up, just like I have here. Let's grab the first command. So, which is, the steps are really the same as for Clang 16 on Windows, but we made sure to use the standard library that comes with Clang. Before we even do anything, let's do ls and remove any PCM files that are generated in this folder. Let's remove any object files as well and remove Rooster. And if we do lsalh, we're going to see our clean folder with some noise coming from the IDE that we are using, but we are just going to ignore this. The important thing are, what we really are focused on are the main CPP file and the math ixx file here. Let's go down and put in the first command, which is going to pre-compile our IO stream into a binary format. So iostream.pcm. This is going to go through. It should give us a warning, but we're going to ignore that. Let's go down and compile our module file into mathstuff.pcm. This is what Clang expects. We put in the command, we compile, and let's grab the next command. This may seem repetitive, but I really do encourage you to do this because this is going to give you an understanding of how these things work, especially the order in which you have to compile things. And these are things tools like the build system, the IDE are going to be helping you with. Let's go back and grab the next command, Clang, to compile the module into object code. So we put that in here and it is going to compile. And we need to put everything together and compile a binary that we can run on Linux. Let's do that. And this is going to go through. If we do ls-alh, we will see all the output here. The most important one being the rooster binary that we can run by running this command here, /rooster. If we run it, we will have the same output we've seen all along. This is really all I had to share in this lecture. The main idea being that you can separate declarations from implementations, and this is going to make your code a little more readable. This is a decision you will make. I will show you different ways to organize your module code, and you will choose whatever works best for your use cases. I am stopping here in this video, and I will see you in the next one.